So for this one, we're going to start in the packet, but a lot of it I'm going to do on Delta Math. So the first thing you'll see is all of our different transformations. So our reflections in the y and x axis, left and right, up and down, and then our stretches and compressions based on if the number is in front of f of x, right, we have a vertical stretch or compression, and those work the way we expect, right, where bigger numbers bigger than one stretch, smaller than one compress. And then if we put that number multiplied by the x, those are horizontal or x direction stretches and compressions, and those work backwards. So if it's a number bigger than one, right, we're going to have a compression, and if it's smaller than one, we have a stretch. So we're going to do a little more like traditional transformation work when we do the classwork, but they just have graphing on Delta Math, so that's what we're going to be looking at now. Now, important things to remember. First off here, I just see a typo. The asymptote, right, the line that it can't cross for b to the x is the horizontal line y equals 0. So if I graph a parent exponential function, it's going to look like this, and it cannot cross y equals 0, which is the x-axis. If I have a logarithmic parent function, it's going to look something like this, and it cannot cross x equals 0 or the y-axis. So when we do transformations, that asymptote is going to move around if we shift things in certain directions, but no matter what, exponential parent functions, transformations of exponential parent functions still always have horizontal asymptotes like their parent function. Circle that in red so it's the same color. Right, so this guy here has a horizontal asymptote even if I move him up or down or left or right. And then transformations on logarithmic parent functions always have vertical asymptotes like this, x equals 0. And we'll write those asymptotes in when they move off the axes as dotted lines. So let's look at our first graph. And honestly, a lot of this is graphing calculator work. We will talk about the transformations. And as I said in class, we'll do more with those transformations. So we're going to be graphing this function. Looking here, when I look at this, there is a negative in the front here, right? So if we put a negative in the front of the function, if we do negative f of x, that's a reflection in the x-axis. Okay. And then if we tack a -6 on the end of the graph, right, we do an f of x -6, that's a down 6. So we should be seeing those things when we look at this graph. If we think about our logarithmic parent function, we should see it flipping over the x-axis and then moving down. So I actually already have this graph from Desmos, and we'll be doing the other ones on Desmos together. This is what the graph looks like, and then this is our table. Now, because we didn't shift this graph back or forth, we are still seeing the asymptote is x equals 0, or the y-axis. It looks like it touches it, but you have to have that knowledge. And also from the table, you can see there's no value when x is 0, and then there's no values back here. So I'm going to switch over to this problem on Delta Math. So what I would have to say here is that since it's a log graph, we have a vertical asymptote. It pops this in. We saw from our graph that the asymptote was here, and that made the graph go away because the points are there. If I look back at my table, I have a point 1, -6, and 2, -7. So the way the Delta Math works, we just take the points and put them there. So we have 1, -6, and 2, -7. Okay. And if I look at my Desmos graph, which I have in the packet, that looks right. So once I get that, I have those points, I put my asymptote in the correct spot, I just click submit answer, and I do that problem. So the rest of them that we're going to look at in the packet, we'll talk about transformations. You don't necessarily need to do them, and then we'll graph them on Delta Math. So first off, this function, and I should have done this back on the other page. Let me go back to that. Oops. So I should have mentioned before I did the transformations in the log graph that the parent function was log base 2 of x, right? That's our parent function. So when we identify the parent function, it's important to know what that is so we can know how it changed. So over here with this exponential graph, my parent function is y equals 3 to the x, right? B to the x, in this case, b is 3. So transformations I see, there's multiplied by 2 on the outside there. So that 2 f of x is a vertical stretch of 2. And then we have f of x plus 1 because the exponent changed to x plus 1. So that is left 1. Okay, so we should expect those things. We should expect a little bit more of a stretched out graph vertically, and then we should expect it to be shifted over. So we're going to go over to Desmos now and graph that. So control 6 is our exponent, or shift 6. And we have x plus 1 shift 6. And one thing you have to do on Desmos when you're up in the exponent is you do have to keep the exponent in parentheses or it will move that 1 down. So just be careful with that. So we see our graph. We see it looks like it's shifted left. It goes up a little more quickly than if we just graphed 3 to the x. So I'm going to go to my table. Okay. Points I'll probably graph this -1, 2, and this 0, 6. So I'm going to go over to Delta Math. And I have these problems already saved. So first off, when I look at this graph, we have a horizontal asymptote. We did not move the graph up or down in terms, there's no up or down transformation. So it is still horizontal at x equals 0. And the points I'm going to graph are -1, 2. And 0, 6. So we flip that around, graph looks good, and submit it. So we have a couple more. I'm going to go straight from here. So this one is another exponential graph, right? So one thing I can know automatically, if it's exponential, it has a horizontal asymptote. Now I see a down 8. So I'm going to talk about things I can kind of tell before I graph it. So that means if the whole graph got moved down 8, I'm expecting the asymptote to be at -8. So we're still going to need to move some points around. I'm going to just talk about transformations here. So we have a in the front and negative. So that's a reflection in the x-axis, vertical stretch of 2. Right here, this x plus 5 is going to move it left 5 and then down 8. So it is really advanced to be able to graph all of that at this level, but we should at least be aware of what's going on and what we should expect. So over at Desmos, and I said you can't even type in the log bases in the Delta Math, I don't think. So Desmos is definitely your best option. So and -2 times 2. Shift 6, parentheses, x plus 5 minus 8. Okay, so I can't even see my graph, but that's because it's been flipped around. So I'm going to move this up. Okay, now interestingly, because we flipped over the x-axis, we actually have a graph that's completely below 8, right? So I'm going to look at my table. And right now, not necessarily the best points because we moved it left. So I'm actually going to go down here. Maybe I'll enter a -5, -6, -7. And I could do more, I could get the -3, -4 as well. What I'm showing here is we can see these points approaching -8 from the lower direction. So going back to Delta Math, I'm probably going to graph -5, -10, and -6, -9. So -5, -10, and -6, -9. Okay, so because of the scale of this graph, we can't really see a lot of it in the same way that we can see this tail here, but that should be good. So one more of this. So that was just the one I was in. So you'll notice that I went out of order. Sorry about that. And I am not going to make this long video again. So the one we just did was on page 39 in your packet. Okay, so I just did this one, and now I need to come back and do this log graph. Okay. So going back over here, log base 3 of -x plus 3 plus 5. Now, it is super tricky when you have this going on and two things are going on in the parentheses. Basically, it's moving left 3 and then reflecting in the y-axis and then up 5. So we can see those transformations. It's a log graph, so I know I have a vertical asymptote. Because I moved it left 3, but then reflected over the y-axis, that's going to be kind of tricky. So we're just going to look at the graph over here. So just as a reminder, when you're graphing a log graph, you have to press shift and then the minus sign next to the 0 to get that base. So this is log base 3. So first off, parent function is just log base 3 of x. Transformations we're adding here. And why don't I shift this up so we can see it? See our graph. Wrong direction. Okay, so there's log base 3 of x, and we're making it -x plus 3. Basically, the way it happens is the left 3 happened first, and then we're reflecting it over the y-axis. And then when I put the plus 5 on, I should see it move up 5. So we'll still drag this down so we can see the graph a little better. It looks like my vertical asymptote is at x equals 3, and I can confirm that with a table. Okay, so if I put my 3 in here, right, I'm pretty sure that that's the point, right? It can go up to 3, but cannot equal 3. So back to Delta Math, I'm going to graph 0, 6, and 2, 5. Move my asymptote over to 3, which will flip the graph around. Do a quick check. 0, 6, 2, 5. Okay, and submit my answer.